So, I'm going to make a little XY chart. X tangent of X. Okay. At 0 radians, what's the tangent of 0? It is 0. Okay. What about at pi over 4? What's the tangent at pi over 4? 1. What about at pi over 2? What's the tangent? Well, let's think about the numbers. The tangent is y over x because it's sine over cosine. Y is 1, x is 0. What's 1 divided by 0? Undefined. I'm glad nobody said 0. Or Mr. Bierschbach would have gotten upset. Because everything's good in life until somebody tries to divide by 0. And then things go south. All right, 3 pi over 4. -1. Thank you very much. Pi. That's 0, because 0 divided by -1 is 0. 5 pi over 4. 1. 3 pi over 2. Negative undefined. Sure, why not? 7 pi over 4. -1. And 2 pi. 0. Okay, so let's see what this dealy whopper will look like. So we'll go pi over 2, pi, 3 pi over 2, 2 pi, 1, 2, -1, -2. Okay, where are we undefined at? Pi over 2, so we're going to have an asymptote there. Where else? 3 pi over 2. Okay. All right, at 0, we're 0. At pi over 4, we're 1. At pi over 2, we're undefined. At 3 pi over 4, we're -1, 0, and 1. -1, 0. So we got kind of a pattern going on here. Okay? Because we're at -1, pi 0, pi over 4, 1. And then -1 at 7 pi over 4, 2 pi, we're at 0. You don't like this? Looks a little funky. All right. All right. So I'm going to go with this middle one here. See how we're going like this? What do you think happens after that? Do you think it goes, or do you think it goes like this? Like that. All right. So that's only one curve, and I kind of like to see 2 curves. So what I'm going to do is throw out another asymptote over here. Throw another point in there and make another curve. And that's what the tangent curve looks like. The tangent curve always has what type of slope? Positive slope. because it's always going up. Always going up. Okay? So y equals a tangent of x is that curve. Okay? Are we good? Okay, now let's do the cotangent curve. Okay. So we're going to graph y equals cosecant of x. No, cosine of x. Cotangent of x. Mr. Biersbach tried 3 times to get it right. Cotangent of x. All right. What's cotangent at 0? So it's now x over y. Undefined. Because it's 1 over 0. What's the cotangent at pi over 4? 1. What's cotangent at pi over 2? 0, because it's x over y. 0 over 1 is 0. What about 3 pi over 4? Negative 1. Oh, I forgot one. Forgot about 7 pi over 4. That poor little chap. 7 pi over 4. And then 2 pi. So 7 pi over 4 is negative 1. And then we get to undefined again. So we have asymptotes on the y-axis here. At pi. That 2 pi. So pi over 4, 1 is a point. Pi over 2, 0 is a point. Pi over 2, or 3 pi over 4, negative 1 is a point. Then 5 pi over 4, 1. 3 pi over 2, 0. 7 pi over 4, negative 1. Ta-da! There's cotangent curves. Okay. So that's pretty easy, right? Now, let's see how brilliant you all are. Okay. Now, hopefully you have the piece of paper with the tangent curve still on it. Okay? Because let's do this. Let's go y equals the tangent of 2x plus 3. Ooh, fun, fun, fun. Y equals the tangent of 2x plus 3. So, what does this 2 do to it? Does it stretch it or shrink it vertically? Does it stretch it or shrink it horizontally? Does it move it 2 up? Does it move it 2 down? Does it move to the left? Does it move to the right? What happens to it? Shrinks it horizontally by twice as much. So, then what does a plus 3 do to it? Moves everything up 3. So when I graph this, because I'm moving everything up 3, I want to put my x-axis down here a ways. Because I'm moving up. So I'll go 1, 2, 3, 4, 5, -1. Okay. So, if I'm going to make, let me just put we'll go 2 spaces, get to pi over 2. And then pi, 3 pi over 2, 2 pi. Okay. So I'll just take a break, let you copy that down, and then I'll talk. Because I don't want to leave you in the dust too bad. Yep, we are going to use that tangent graph we used earlier. Okay, everybody ready to roll? Okay, now, looking at this tangent graph, see how we had an asymptote at pi over 2 and an asymptote at 3 pi over 2 and then 5 pi over 2. If I have tangent of 2x, everything's twice as skinny, everything shrinks down by 2. How many spaces did I go over to get to pi over 2? 2. So I'll go over 1 space and have an asymptote. Instead of going over 6 spaces to get to the next asymptote, it'll only be 3 spaces over. So I'm going to put in my asymptotes right now. I'm going to just pick a different color. I'll go green. So I'm going to go 1 space to get to an asymptote. My next one will be at 3 spaces over. So how many spaces are there in between my asymptotes? 2. So I'm going to just throw an extra one in here just because. Okay, we good with that? Now I got my asymptotes. I'm going to go back up and look at this again. Okay, halfway in between my asymptotes, where was I? 0, right? I'm 0 halfway in between. And then halfway in between that point and my asymptote, I'm up at 1. And halfway in between, I'm down 1. Now, I'm going to move every point up 3, right? Because it was plus 3. So the 0 will actually be up 3. So my 0, which you would think would be right there, is actually going to go up 3 to there. That's my 0. Okay? Then halfway in between this and my asymptote, I should be up how far? 1. Because halfway in between here and here, I went up 1, right? So if I go to here, halfway in between here and here, I should be up 1. So I'm going to be actually halfway in between these. So not right on 1, but halfway in between. Okay. So if I go back this way, how far am I going to go down? 1. So there's my dots. They're in the right places. Okay? Because I made everything twice as skinny, and up by 3. So I'm going to put dots here, here, and here as well to mimic for those. And then I'll be super close to my asymptote and make a little slide over and be super close to my asymptote. So it's going to look like that. Okay? Capiche? Okay. Let's do a cotangent one now. How mean am I going to be today? Let me look. Plan book. Law. Oops, this is not the right day. That's February 1st. Cancel. Let's. Yeah, and it won't let me log in. I have to like get all the way out and get back in. That is totally inconvenient. I get all the way out, and I have to log back in, but it logs me right in right away. So it's, yeah, and I lied. It logs me in right away. It should take me to this week. Okay, so here we go. We are on Tuesday, 33, 37, 43, and 45. I just got to make sure I cover what we will do without tripping you up too much. 33, yep, 3 times as skinny. 37, ooh, yeah, I do that to you. 43 and 45. Okay, so, all right, here we go. Let's do a couple more. So, let's do this one. Y equals cotangent of x over 4 minus pi over 2. Nah. Let's just go x over 4. I don't need to like totally confuse you. Okay. Cotangent of x over 4 means the same as the cotangent of 1/4 x. What is 1/4 x going to do to the graph? Stretch it way out. Like a lot. Like how many times out? 4 times out. Okay. So if it stretches it 4 times out, I need to get to like 8 pi out here somehow. Okay. So I'm going to go like that and make each of these pi. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. 1, 2, -1, -2. All right. So I'm going to zoom on up here to my cotangent one. Okay. Where were my asymptotes? At 0, at pi, and at 2 pi. Okay? 0, pi, and 2 pi. So if it's 1/4 x and it stretches it 4 times wider, instead of being at pi, I'm still going to be at 0. Because 0 times anything is still 0. But instead of being at pi, where am I going to be at? 4 pi. Instead of being at 2 pi, where will I be at? 8 pi. There we are. Okay? Now, this is how I think of tangents and cotangents. You don't worry about where the dots are. You worry about where your asymptotes are and where your dots are in relation to the asymptotes. So, in relation to the asymptote, I'm at the x-axis halfway in between these two asymptotes, right? And since I'm not going up or down or left or right or anything, I just stretched everything out. So halfway in between, I should be there. Halfway in between, I should be there. Now, Cotangent has what type of a slope? Negative. Okay, so I should be going down. So halfway in between here and here, where should I be at? I should be at 1. And halfway in between 2 pi and 4 pi, where should I be? Negative 1. So it should come down like this. And then I repeat that. I always like 2 cycles when it comes to tangents and cotangents. So we make sure you know what you know. Okay? Okay, let's do one more, and then I'll let you get on to your assignment. So let's say y equals negative 1/2 tangent of x minus 1. Okay, now what's this negative 1/2 going to do? Flip it over the x-axis and make it half as tall. So, yeah, shrink everything down vertically. And then the minus 1 will do what? Move everything down 1. Okay. So, are we shrinking it left or right at all? No. We're not moving anything left or right. So, I'm just going to go 2 squares to get to pi over 2. And another 2 squares to get to pi, and so on. So, pi over 2, pi, 3 pi over 2, 2 pi, 1, 2, negative 1, negative 2. All right. So, where are my asymptotes of tangent, my original tangent curve? Pi over 2, 3 pi over 2, 5 pi over 2. Does that change for this one? Will the asymptotes change? Am I going moving anything left or right, making things skinnier, anything like that? Nope. So it should be the same. So let's make them the same. So I have an asymptote at pi over 2, 3 pi over 2, and then I'll go another one at 5 pi over 2. All right. So halfway in between for tangent, I'm at 0 normally, right? Halfway in between my two asymptotes. So halfway in between, I should be at 0. 0 times negative 1/2 is still 0. And then I got to drop it down 1. So I should be here. Because halfway in between, I should be at 0, but I drop it down by 1. Okay? So I'll throw this one there too, just because. All right. So normally on the tangent, halfway between this dot and this dot, or halfway between here and here, halfway between my first dot and my asymptote, I'm up here by 1, right? Go up by 1. But if I multiply this 1 by a negative 1/2, where will I end up? Negative 1/2. I should end up right there. And then what's going to happen to that? Go down by 1. So I'm at negative 1/2. Okay. Then going this way, I was normally down by 1. But if I multiply by negative 1/2, I'm up by 1. But then I go down by 1 with a slide down by 1. I should be here. So what happened to it? It made it look like what curve? cotangent because I now have a negative slope. When you flip it over the x-axis, you're going to have a negative slope. So it looks like that. So there you go. That is graphing tangents and cotangents. All right, so you're going to have a good almost 45 minutes, half of a class period to work on four or five problems maybe. How many problems? 4 problems. Only lesson today, 33, 37, 43, 45, I think that is.